Right on time. So for those of you that joined us in the middle of the presentation, these sessions will be rather short, so I'd invite you to engage our speakers after their sessions or in their booths. Ericsson has a very large booth just outside here. So our next speaker is Thomas Morin, and let me bring up his presentation. There we go. Thomas has been at Orange Labs for a little over 10 years. He's a regular contributor to the IETF, and he is actually the co-chair of the BGP VPN working group. So, Thomas.
Thank you. So, as you understood, BGP MPLS VPNs are a core topic for telcos. The presentation by François was a very good introduction to this presentation, actually. So what I want to talk to you about is the topic of how to interconnect Openstack Neutron and BGP MPLS VPNs. So BGP MPLS VPNs are a key building block to the engineering of most, if not all, provider backbones. And today we have more and more infrastructure as a service platforms which are at the edge of these IP MPLS backbones for public cloud, for the internal cloud, which can carry today platforms and OSS. Of course, for today and more tomorrow for NFV POPs. And we need to interconnect BGP MPLS VPNs with these infrastructure as a service platforms. So while OpenStack is not the only option for doing infrastructure as a service, it is seen today as a key choice for the foundation of infrastructure as a service platforms, whether they are for the public cloud, for the internal cloud, or for NFV. So the question becomes how to drive the interconnection between OpenStack networks and routers and BGP MPLS VPNs. So today, we can already choose an SDN controller, X, Y, or Z, that has this ability to create connectivity between VMs and BGP VPNs. The example given by François is one among a few others. If we do this, we will have to use the specific API of X, Y, or Z to drive these interconnections. And in many cases, you will have to be acting as admin to create these interconnections, and Lambda tenant credentials won't be enough. So this is good, but this is not good enough. So the goal here is to have a single controller agnostic API to drive these interconnections, and have an API that will allow each tenant to drive their BGP VPN interconnection themselves in a self-care fashion. And additionally to these two goals, we also want to have this feature in Neutron itself as an additional deployment option to the deployment option consisting in using an SDN controller. So, practically speaking, what are we talking about? What I want to discuss today is a new project into OpenStack, which is called Networking BGP project. It's a project in which we work on a service plugin that inserts into Neutron and exposes an API to create this BGP VPN interconnection. It will allow, I will explain a bit more afterward, it will allow a tenant to say, I want network X to be interconnected with BGP VPN 2. And then how this interconnection is realized will depend on the driver and the backend that we want to use. But before jumping into the details, I will give you a little bit of a perspective on how this came to life. So the API proposal was actually started a bit more than 2 years ago by Nachi Ueno and Pedro Marquez, which are at Contrail. And we restarted this effort at Orange roughly 1 year ago, giving to the community an implementation as a starting point, open source, of course. And this implementation has the characteristic of being independent from an SDN controller, which make it more acceptable and easier to integrate into the practices of especially the testing practices of the OpenStack community. So this proposal triggered interest around the OpenStack Summit last spring, and at the same time, the OpenStack community was reorganizing its process to open the door to a new project. This is what they call the big tent approach. So we were we are having all the ingredients to create a new project inside OpenStack, which was done in early last June. So let's look at sorry, I need to keep close to the mics. So let's look at the different components that we use to make this happen. So on the one hand, you have Neutron, which is already, of course, already existing, the network component of OpenStack. And on the other side, you have BGP MPLS routers and BGP MPLS networks. So what we add to the picture is first the BGP VPN service plugin that we'll insert into Neutron. And as soon as an API call is made through the API of this BGP VPN service plugin, using a driver specific to the backend that we want to use, the work will be delegated to the backend. The backend can be an SDN controller. OpenLite is an example that was detailed by François just before this talk. OpenContra is another option that we can use today. Nuage Network is another one. There could be many others. And you have also the option of just using Neutron with a lightweight extension to do BGP VPNs. But in the end, the result will be the same. Routes will be exchanged with BGP peers, so BGP VPN routes. And the data plane will be configured to receive and send the packets exchanged between VMs and BGP MPLS VPNs as MPLS traffic. So as François mentioned, the encapsulation can be MPLS, it can be MPLS over GRE, MPLS over UDP. It could be VXLAN as well. So this is kind of the big picture. So I mentioned API calls to define interconnections. I need to talk to explain you a bit more about this. So to create these interconnections, we need new abstractions, new objects in the API. And the first one that we added is called the BGP VPN resource. It contains all the details about a BGP VPN. Its type, it can be an IP VPN or an EVPN. Technical details such as BGP road targets that define the VPN. Basically, it can be seen as a VPN identifier for simplification. And this object is created by the OpenStack admin. Of course, a tenant cannot itself choose the technical details of BGP VPN. But once that this object is created, it is given by the admin to a specific project. In this example, it's called Project Lambda. And then a user in the Project Lambda will be able to use this object to create interconnectivity between the corresponding BGP VPN and already existing network resources, such as a Neutron network or a Neutron router. And this these interconnections are created by creating association objects, network associations, or router associations, depending on what kind of connectivity you want to create. So these are the new abstractions that we introduced to allow the definition of interconnectivity between OpenStack resources and BGP VPNs. So let's look at one deployment option, which consists in using the existing, for instance, Open vSwitch driver of Neutron with a lightweight extension to do BGP VPNs. In this case, when an API call is made to create an association between, for instance, a network and a BGP VPN, the backpipe driver sitting in the BGP VPN service plugin will, through the OpenStack message bus, talk to an agent sitting on compute nodes. So the agent is a component that already exists when you use Neutron with Open vSwitch. And what we added is a simple extension to this agent that allows to pass VPN information to the component that will actually talk the language of BGP MPLS VPNs. So BGP extensions to consume and produce BGP VPN routes. So the next step consists in exchanging BGP VPN routes with BGP peers and configuring the data plane locally for MPLS forwarding so that VMs can exchange traffic with MPLS VPNs. Now, we can also look at the other typical option that can be used with this BGP VPN service plugin, where an SDN controller is used. So as I said already, the SDN controller can be, it could be many SDN controllers. Today I will explain, we have drivers for Open Daylight, Open Contrail, and very soon you have networks. So in this case, when an API call is made, the work will be delegated to the SDN controller via the driver specific to this SDN controller. So typically, it will use it's typically a REST API to reach the northbound interface of the SDN controller. Then the SDN controller will do whatever it has to do, depending on the internal conception, to exchange BGP routes and control the states on the virtual switches, or actually it can be also physical switches as well, to, in the end, be able to exchange traffic between VMs and MPLS VPNs. So today, where are we? We had the first release done in the middle of December last year. It's a release that works with Openstack last release, Liberty. It has already a stable set of base features, so the ability to create BGP VPN definitions and network and router associations. It also has, it's kind of the base typical use support for an extension of the Neutron CLI for the corresponding API objects. And more important, it includes drivers for this Neutron backpipe combination, compatible with the Open vSwitch driver in Neutron. It has a driver for Open Daylight, a driver for Open Contrail, and a driver will be coming very soon in a separate repository for the Nuage Network SDN controller. And beside this release that was targeting Liberty, that works with Liberty, we also have backports that are ready and available for the two previous OpenStack releases, Juno and Kilo. So this release, this work didn't came from anywhere. I want to give you an idea of the contributors behind this. So as I said, the work was kick-started based on an implementation that Orange made open source. So in the early days, the contributors, the level of contribution from other players was a minority. But today, we are very happy to be able to see a very significant increase in the diversity of contributors. We can in particularly name Ericsson and Nuage Networks as key contributors to the project. And, well, we have more and more contributors to this project, and we are very happy with that. So, very related to this diversification of contributors, I want to also give you a word on OpenNFV in the context of this BGP VPN project. It happens that the OpenStack project has a peer project in OpenNFV, a project called SDN VPN, and that resulted in the last release of OpenNFV, which happened last week, to include, as part of OpenNFV, this Neutron BGP VPN interconnection service plugin, along with a driver for Open Daylight. And practically speaking, what happens through this OpenNFV project is a set of very useful contributions around the OpenStack work, and more precisely, contribution on installer support for Fuel and for Apex, and functional testing, so contribution for Tempest testing, and contribution to the FunkTest OpenNFV project. So more will come this year for the next OpenNFV release. But the key point and the key takeaway here is that we have seen through this project in practice how OpenNFV can be a very strong catalyzer for telco work in OpenStack. So what is next? So the next release will target, of course, the next OpenStack release, Mitaka. We already have new features, hit support that was contributed by Ericsson, and improvements to the Neutron backpipe driver for better integration with the Neutron agent. And planned, we also have a work in progress for an integration in the OpenStack dashboard, Horizon, driver support for EVPN, because for EVPN, while the API is already here, the API already is ready to support both EVPN and IPVPN. But we need, we have some work to do for to have all the proper hooks into the different drivers. We also will move forward with work on static routes, adding the ability to say that a given prefix is behind a given port of a VM, and also work on prefix aggregation, giving the ability of the admin to control whether /32 routes will be advertised or whether aggregate prefixes will be advertised. So this is really kind of a short-term roadmap for the project. We can also briefly mention other scenarios which are on the radar and very strongly related to infrastructure as a service and BGP VPNs. One of the topics is the interconnection between multiple tenants inside one data center. So already the typical way of doing that relies on floating public IPs, which works, but which has significant constraints. And using BGP can be an alternative to this floating IP approach. It's particularly relevant in an NFV context where a coordinated use of the private address scope is possible. It can also extend to other contexts as well. But we see this as an interesting approach to explore. And the other topic that I want to mention, even though we don't have time today to get into the details, is the topic of interconnection between multiple data centers or multiple POPs in an NFV context. So in this context, of course, BGP VPNs, whether they are IP VPNs or EVPNs, can be leveraged to build inter-data center connectivity. But the question that remains to be explored is what API we can use to control this. One possible way is to rely on pre-allocated BGP VPN objects, pre-allocated by the admin and given to the tenants, which they can use to create connectivity when they want. But this kind of pre-allocation model is not really the ideal in a context where we prefer to have everything created on demand. So we have a work in progress to work on a new API model to be able to create these interconnections on demand. So to wrap up, this is about a new service in Neutron to allow the tenants to have themselves the control over how their Openstack networks and routers are interconnected with BGP VPNs. So it's one single Neutron service and API. So it's a very strong unification of the different myriad of API that you can have on SDN controllers. But of course, it has mappings for the different SDN controllers, including your preferred SDN controller. And it's also usable without a controller if you prefer this approach. So for us, this is a really a practical one-year illustration of a possible way to do telco-specific work in OpenStack Neutron. And to conclude, I want really to say again that we were very happy to have been joined by others, having this mutual interest in moving forward with an extension to the Neutron API to create BGP interconnections. And I encourage you to have a look at the list of contributors here. All these people contributed to the networking BGP project in OpenStack. So this is what I had, and I will welcome any question you may have, because maybe we have 1 or 2 minutes left.
We have 1 minute, so if you have questions for Thomas, if you could just state your name and affiliation before you ask your question. And speak loudly, because I think we don't have microphones to hand out like we did yesterday.
Yes, one question, actually. Is it used already in your production for the Orange network?
So the question is whether we use it already in production in Orange. I wouldn't be able to tell you precisely if it was done yesterday or if it will be done tomorrow. But CloudWatt, which is a company which was affiliated to Orange and which is now part of Orange, is using this in production to control the interconnection between Openstack tenants and router attachments. So it is used in production, or will be tomorrow, with Contrail as the SDN controller.
Okay. Thank you.
Maybe another one?
Yeah. One more.
Is there a way to limit the access to VPNs of a tenant?
So the question is whether there is a way to limit the access of a VPN to a tenant, of a tenant to a VPN, sorry. I'm not sure how to interpret your question. So the admin creates a BGP VPN object and gives it to a tenant. So a tenant will only have access to the BGP VPN that the admin has given him access to. So by default, and it's the key, the core, of course, of the model is that a tenant cannot access a BGP VPN of another tenant. So, yeah.
Okay. Thank you, Thomas.
Thank you very much.